Hello everyone and welcome to the first video in a little mini series that I decided to start. This series really is primarily for students and brand newbies who are just starting to learn the basic principles of land surveying and the basic math. So if you're licensed or if you've been doing this for a long time, all of this information is already in your noodle and this video really isn't for you. This is really for people just getting started who maybe need some short form video content to kind of help them with some of the basics. So today we're going to be converting azimuths to bearings. I always start by drawing myself a picture. This will really help you memorize these formulas, and it'll help you overall in school and beyond to just get used to drawing pictures of problems, especially as they get more complex. So we're going to give ourselves the cardinal directions here and then talk about a couple of things that we need to remember about azimuths and bearings. Azimuths, we always start at 0 and we travel clockwise to 360 degrees. Azimuths are never negative. An azimuth is essentially a horizontal angular distance from a known reference direction. We typically use north. And bearings are never going to be greater than 90 degrees, so keep that in mind. So we've broken this circle up into quadrants, and we're going to start with the simplest one. If you are given an azimuth in the northeast quadrant, which would be from 0 to 90 degrees, the azimuth is equivalent to the bearing. They are the same. The only difference is that you need to add the direction to your bearing. So this one, super easy to remember. Anything between 0 and 90 is the azimuth is the bearing is the azimuth. Nice and easy. In the southeast quadrant, so we're talking 90 to 180 degrees, you're going to take 180 degrees and subtract the given azimuth to calculate your bearing. Alright, so if we are going to be converting an azimuth to a bearing that's been given to us in the southwest quadrant, so between 180 and 270 degrees, we're going to take the given azimuth and subtract 180 degrees to calculate our bearing in that quarter. And finally, I think I erased this just to be consistent in my formatting here. Okay, so in the northwest quadrant, you are going to take 360 degrees and subtract your azimuth to calculate your bearing. So there are the formulas. And now let's jump into some examples. I think I'm going to give one in each quarter. So, like I said, if you're given an azimuth of 50 degrees in the northeast quarter, so 0 to 90 degrees is the northeast quarter, the bearing is equivalent to the azimuth. We just add that direction. So an azimuth of 50 degrees would compute to a bearing of north 50 degrees east. If you're given an azimuth in the southeast quarter, let's say of 160 degrees, you're going to take 180 degrees, subtract that azimuth, so in this case it would be 180 minus 160, and you would get 20 degrees, and then add your direction, so south 20 degrees east. Let's do one in the southwest quarter here. If you're given an azimuth of 260 degrees, I think is what I chose here, you're simply going to take that 260, subtract 180 from it to calculate your bearing. So the bearing in this case would be south 80 degrees west. Okay, and lastly, let's calculate one up in the northwest quarter. If you're given an azimuth of 300 degrees, you're going to take 360, subtract your azimuth to calculate your bearing. So the bearing in this case would be north 60 degrees west. Like I mentioned in the beginning, if you calculate a bearing that's greater than 90 degrees, or if you somehow come up with a negative azimuth, don't press forward and collect $200. Go back and try again because you've done messed up somewhere. All right, I'm going to give you guys a couple of practice problems here. Here's an azimuth in each quadrant. Feel free to compute these and leave a comment with your answers down below, and I will let you guys know if you're correct or not. Thank you so much for watching. I hope this was helpful. Bye!